Alright, welcome back to Scholar Strive, doing some math. Today we'll be working in Algebra II, section 5.3. We're going to be working with adding, subtracting, and multiplying polynomials. Now, adding and subtracting should be easy for you, but I'm just going to do it in two different ways. One way that we're kind of normally used to, which is the horizontal way, and then the vertical way. I know you've seen this before, but here we go. This is how it works. So we have 2x cubed minus 5x squared plus 3x minus 9. And we want to add the polynomial x cubed plus 6x squared plus 11. So to do it vertically, all you do is line up your x cubes. So I have 2x cubed here, and then I have x cubed here. And then your x squared values. And then your x's. So in the second polynomial, x cubed plus 6x squared plus 11, there is no x value, so we're just going to put 0. And then our constants, minus 9 and 11, and then we're just going to add them. Now this is very similar to, you put the thousands in the thousands place, the hundreds in the hundreds place, and so on and so forth. Just a little bit different because we just have x's and stuff like that. So we just add all our like terms together. So negative 9 plus 11 is positive 2. 3x plus 0 is a positive 3x. Negative 5x squared plus 6x squared is 1x squared, and that's also positive. And then 2x cubed plus x cubed, or 2 apples plus 1 apple, is 3 apples, so 3x cubed. And that's how we do it vertically. How we did it originally is we have, in parentheses, 2x cubed minus 5x squared plus 3x minus 9. And then we're adding x cubed plus 6x squared plus 11. And some of this threw you guys off on the last test when we had smaller values. It looked like, because we only had 2 terms in one and 2 terms in the other, so it looked like a FOIL. But there's a plus sign here. Okay? And when there's a plus sign, we can remove our parentheses because in PEMDAS, we're just adding and subtracting. They're reversible. There's nothing to do. Okay? And that's all 11 there. So you just combine your like terms and you'll end up with 3x squared plus x squared plus 3x plus 2. Another way to look at it is this positive 1 here is being distributed to all 3 values. That's one way to look at it. So subtract 3x cubed. So yeah, that's that problem. Next problem. Subtract 3x cubed from 2x squared minus x plus 7 from 8x cubed minus x squared minus 5x plus 1. So we got to be careful on this because when we say, I'll just use a different example, subtract 2 from 3, that is 3 minus 2. Okay? So the wording is important. Okay? And it will change your answer. So we're subtracting this thing here, this first thing, from here. So if you want to write it vertically, I'm going to put 8x cubed up top. So 8x cubed, and then put 3x cubed here. And then we have minus x squared minus 5x plus 1. And then here we have 3x cubed plus 2x squared minus x plus 7. And then we're just going to subtract. So 1 minus a positive 7 is negative 6. Negative 5 minus a negative 1 is negative 5 plus 1, so this is negative 4x. This becomes minus 3x squared, because this is negative x squared minus a positive 2x squared. And then lastly, 8x cubed minus a positive 3x cubed, which is 5x cubed. So there we go. And then horizontal, 8x cubed minus x squared minus 5x plus 1 minus 3x cubed plus 2x squared minus x plus 7. Trying to avoid my record button. So remember, this negative 1 gets distributed to all these, and then you combine like terms, and you should end up with 5x cubed minus 3x squared minus 4x minus 6. Okay? So how the step before will look like this. 8x cubed minus x squared minus 5x plus 1 minus 3x cubed minus 2x squared plus x minus 7. Alright. Alright, so we're going to multiply these two polynomials vertically, and then we'll do it the normal way where we're used to, the horizontal way. So vertically, I like to, whenever we're multiplying two things, I like to put the largest polynomial up top. So the largest polynomial means one with the most terms. So the second one has 3 terms, so 3x squared minus 2x plus 4. And then I'll put x plus 3 here for the other one. And we're going to be multiplication, or if you want a big X. I don't like to use X's because the obvious variable X, but we're multiplying here, and this is how it works. It's kind of very similar in how you did some old, with multiplication with larger numbers like 12 times 13. But here's how it works. So we take our first value here, which is 3, and then multiply everything in the top. So 3 times 4 is 12. 3 times negative 2x is minus 6x. And then 3 times 3 is 9x squared. Okay? And then, just like if we did a normal multiplication problem, I would add a 0 there and then go to my next number and multiply the top. So x times 4 is 4x. X times minus 2x is minus 2x squared. And then x times 3x squared is 3x cubed. Okay? And then we just add everything up. So this is 12 minus 2x. So that's a positive 12. Negative 2x. 7x squared. And then 3x cubed. Okay. So what I was saying before is if we had a normal multiplication problem, I would multiply the top by 2. So I get 22. And then when I move on to the next number, I just add a 0. And then do 1, 1, and then add everything. It is very similar to that. But this once again is just to show an example how similar it is. I'm just gonna erase it now. Alright, horizontal. Doesn't matter how you arrange it. I just like my lowest amount of terms on the left and then highest amount on the right. So this is x plus 3 times 3x squared minus 2x plus 4. Okay? So I'm going to take my x value and distribute all the way here. So these three numbers. So I got 3x cubed minus 2x squared plus 4x. And then I'm going to take 3 and multiply to everything. So 3 times 3 is 9x squared minus 6x plus 12. And what do you know? When I combine my like terms, I get 3x cubed plus 7x squared minus 2x plus 12. So same stuff. Alright, number 4. A minus 5, a plus 2, a plus 6, all three of those are going to be multiplied together. So, what I like to do is focus on the first two and just FOIL it like normal. So I have a squared here plus 2a minus 5a minus 10. Combine my like terms, and I'm going to put this in parentheses, a squared minus 3a minus 10. And then we have a plus 6. Okay, and then I'm just going to, again, have a be multiplied to everything. So I get a cubed minus 3a squared minus 10a. And then this number here is a 6. And that gets multiplied to all three of these as well. So plus 6a squared minus 18a minus 60. Combine our like terms and I'll get a cubed plus 3a squared. Sometimes when I have a long list of things, I like to check mark things that I already have. So the first one, a cubed, is all by itself. And then we have a negative 3a squared and a positive 6a squared. When you add them together, you get positive 3a squared. And then I have negative 10a plus a negative 18a. So that is a negative 28a. And then lastly, minus 60. And that's it for that one. So let's look at some special patterns. This one we should recognize, a plus b, a minus b, that was directly from our factor book. That would be equal to a squared minus b squared. So I'll show you an example. X plus 4, x minus 4. This is in the form a plus b, a minus b, where a is x and b is 4. So this, if I FOIL it, I will get x squared plus 4x minus 4x minus 16. So that equals to x squared minus 16. Okay. Cube of binomial. This is also in your factor book, but I'm going to rewrite it out. So if we have a plus b to the third power, that's going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. And then if we have a minus b to the third power, we have a cubed minus 3a squared b plus 3ab squared minus b cubed. So it'd be awesome if you could memorize these cubic binomial. You should definitely memorize sum of difference. That should be easy to memorize. But even if you don't memorize these, you can always brute force it. What I mean by brute force is, remember that a plus b to the cube is just a plus b times a plus b times a plus b. You FOIL the first two, and then you distribute a to all the numbers there, and then b to all the numbers. Just like what I did in the fourth example. So remember, you can always brute force it, but it'd be a lot quicker if you remember these special patterns. But if you can always brute force it, that's fine too. It'll take longer to do, but you'll get there. Alright, that's it for 5.3. Homework's in the book, I think.